We have the last presentation today in the speakers tent is Peter Stucke, who's going to talk about SimpleX chat, simple messaging with unusually good privacy. Let's give a round of applause for Peter.
Thank you very much. So yes, SimpleX chat. It's a messenger. I want to talk a little about why it is better than many other, maybe most, maybe all. I'm going to go into a bit of propaganda about good technology and bad technology. I feel very strongly about that. Talk about some good messengers and then compare with this, which I find is an unusually good messenger. I'll talk about what client software there is. I'll talk about the feature set that works already, and then I'll talk about what's on the roadmap for this project. Maybe we'll look into the protocol. It's a little bit complicated with this other computer because of the graphics. And then thank you and questions. So good technology and bad technology, right? This is, I don't know if you've thought about this before, but why another messenger? You may be thinking, and I say, well, most of the messengers out there are really bad technology. And please make an effort to get friends and loved ones away from this bad technology that a lot of people are using. Most of new technology is actually really, really bad. It's not made for us, it's made to make money off of us in some way or other, right? And I argue that this is why the internet has come to feel so bad lately, right? When many perhaps were around in the beginnings of the internet, and then when it was all fun and exciting, but now it's really not so much fun anymore. So the thing is, you are valuable, right? Everybody who's dealing with technology, who's using technology, is really valuable. And by choosing what you use and what you do not use, which is very important. I find that we talk way too rarely about not using technology, choosing to reject stuff that is actually bad, right? By choosing what you use and what you don't use, you're determining the value of technology, because technology is worth nothing if nobody uses it. So there's this reverse network effect. Maybe you heard of the network effect. The more people use something, the more powerful it becomes, and the more difficult it is to switch to something else. Well, if we start to move away from technology and choose not to use technology, then we're also helping get rid of that technology, which is really what we should do, because it's not in our interest. So whenever we use bad technology, we also help increase its value. We are sort of actively supporting this bad technology. So don't do that if you can at all avoid it, right? It's important to reject bad technology. Enough propaganda. So some bad messengers, like WhatsApp is a bad messenger. It's a centralized system, it's US jurisdiction. It's even forced centralized, right? There's no way to integrate with this system, really. It's closed. It also uses strong identifiers, so it's not so privacy optimized, privacy friendly. It's the full name, and it's closed source, so it's also really hard work to find out what is it actually doing. Signal is surprisingly similar to WhatsApp. The main difference is that it's open source. Meh. It's especially the way that Signal uses phone numbers as identifiers, I find is an absolute disaster and completely rules out using Signal for anything. And Signal is also a centralized closed system because they refuse to federate with anybody else, right? Then we have, for example, Telegram is another bad technology. Nobody knows what that is, where that's based. But it's still centralized and it's closed. You can build bots and stuff, but you can't really run your own server, as far as I know. And the security properties are non-existent to unclear is what I wrote. Like if you have a group in Telegram, anybody can just connect and download all of everything that has been said there. And for the like direct chats, I'm not so sure what is really going on there. And it's also closed source, right? And it's the identities and a bad situation, all of these. And there are more bad examples, right? But the slide is full. So let's talk about SimpleX, and I find that I call it an unusually good messenger because it does a lot of things really, really right. I'm not involved in the project in any way. I found it a couple of months ago, and I looked through it, not the code, but the protocol and the design. I was really happily surprised. It was refreshing. So there are no global user identities. There's no way to recognize the same user. Means there's also no discovery or search. So there's no way to find people inside the system, which I argue is a really good thing. That means we have to create connections explicitly when we meet or over some other channel. And why I think this is a good thing is that we have no spam. It's impossible to get spam in. Or, I mean, if you do get spam, it's from somebody you know, because you connected with them, right? So invitations is what is used to create a connection, and it can be a QR code, or it can be just a link that you share over some other medium. And once you've connected, you can also verify. If you meet later, if you're not connecting in person, you can, when you meet at some later time, you can verify that your connection is really not man in the middle by anybody. Invitations there are two kinds. That's kind of fun. I haven't seen that anywhere before. They can either be single use. That's sort of the normal case for adding one contact, adding a new contact. There's only one chance to use it, and then it gets locked in. Or it can be multi-use. That's like a public invitation to join a group, or maybe to contact me. If I want to, I could do that. And these are both revocable. So at any time, I can also stop the invitation, and anybody who tries to use it after that will not be able to connect. And that's really nice. Nice properties. Then there's this incognito option, which is a lot of fun. So because there are no user identities, right? How do we, what can we do with that? So we can have the situation where my client uses a different identity in every context. So it has a different identity for every person I'm communicating with, and it has a different identity in every single group that I'm a member of. This means that somebody that I'm communicating directly with, they cannot know whether I am a member of some chat groups. And that may be really, really useful for me. Normally clients, or I don't know about normally, but clients do have the possibility to probe group members. So if you join a group, you can send a probe to everybody to sort of check if they are known to you already. Switching on this incognito option makes that not work. Right? Then it just, you will have duplicate contacts perhaps with the same name, and and be none the wiser. It's, the server architecture is delightfully simple. It's a very simple server. It doesn't do much of anything. It's a message queue, just receiving messages and sending them out. There's crypto and so on, of course. But the server doesn't know very much or really anything about the contents. And the servers are decentralized. There's not one single server. You can have your own servers, and there are many servers already in operation. And it doesn't really matter which server you use. You can also move servers, like change servers at will. That's also fun, a nice new concept that I haven't seen in really anywhere before. The protocol is layered. That helps with this. So I wrote like TCP/IP. That helps with the separation that the server doesn't really know. It only takes care of transport, messages going through. It doesn't know the contents. Only the clients know what's inside the messages. Of course, the server can see IP addresses, but we can use Tor and maybe other methods as well in order to not show our real IP address if we want to. And the way the protocol works and the way this sort of loose server architecture or flexible server architecture works allows the servers to not really have a lot of persistence. They don't need to store much information, which I also find is great. Of course, a malicious server could still store everything, but the common case, the happy path, is that the server doesn't need to store really anything at all, almost, but very, very little, which is also a really good thing. And this is very different from Matrix, for example, where the server has to store everything about everybody since forever. Don't use Matrix. So what about the client software? What is available right now? There's the command line software. It's the original implementation of the SimpleX chat protocol. It's written in Haskell. Runs on at least Linux, Mac OS, and Windows. I don't know that anybody has tried it on BSD, so please do that. Then there are mobile apps for Android and iOS. It's young-ish. The first version was released in March last year, 2022, and by now the Android version is up to version 5.2. So there's quite a lot of development going on, and I've been using it for 2 months, just about, and I've had 2 updates so far. So about 1 update a month with a few new features in the first one, and 1 new feature. Red acknowledgement, like a second check mark in the last update. So download you can from F-Droid. It's already available there. You can get the APK file directly from upstream, but use F-Droid. It's better. You get the updates, and it's also signed and so on. It's even available in the Play Store. Get F-Droid instead. And the Android app, I feel, works really well. I'm happy with it. Using it for a couple of months. It's written in Kotlin. iOS, I haven't played with that, but I have a couple of friends who are hostage in iOS, and they are able to communicate with me, and I'm with them, and it's fine. Everything's fine. Feature set, so it does text messaging, of course. That's the really basic stuff, right? You can also send links. They are a separate message type. Links can contain a preview. The preview is created on the sender side, but there's an option to disable this. So you just send the link text and nothing else, like the link address. But if you have the option on, there's a pretty graphics of the web page that the link points to. You can send also attachments, images, and any other kind of file, but images are then displayed in the conversation. Supports replies, so you can quote a previous message, supports forwarding, and if enabled, it allows to delete messages also in conversations. Secret chat groups. The chat groups are quite fun because they are not stored anywhere except on the clients. So the server doesn't know that there is a group. It only sees lots of connections between people, or like between clients, right? And they are no different from one-to-one connections. So a group looks for the server exactly the same as many person-to-person connections. That's nice. It works fine to create groups and manage groups. It also supports audio and video calls. That works as well. Uses WebRTC, so the privacy benefits of the SimpleX message queue protocol are lost. But well, it works for calling, and if you enable Tor inside the app, I don't know what happens with the WebRTC. We should investigate that. That's on my to-do list. But anyway, the calling works fine also. So these are some to-dos on the roadmap at the project. They want to do this, as I mentioned, right? We can change servers, change which server is being used for an established contact. That can be done manually at the moment, but they want to make that automatic, I guess, every now and then, change server and or just replace the queue that is being used. When contacting somebody using an invitation, they want to add sort of an introduction message of some kind, some encryption for local files stored, navigation and search inside the conversation. Larger groups, so I don't know where the cutoff is, but it seems that there is some kind of scalability limit, right? Because there is this everybody to everybody connection or situation in the groups. I can imagine that if doing really thousands or 100,000s of people in a group, that doesn't scale so well. So I'm interested to see what they come up with there. Ephemeral, like disappearing conversations, sure. Sharing location, sure. I don't know about this web widget stuff, not so much for me. But okay, I guess. Programmable automations, like maybe vacation replies is the classic one. And then there's, I think, a big one that really, it doesn't matter so much to me personally, but multi-device support, I think, is really valuable for a lot of people. And I look forward to that working as well. And then for those who want to, they want to help create easier discovery, something based on DNS. And then this message delivery relay for senders is something, I think, like what Tor does as well, with you add extra systems in front to just not show the exact IP address you're using and still get messages delivered. That's also fine. But yeah, I like the general sort of ideas that they have in the roadmap. I think this is fun, and especially the multi-device support, I think, will make a big difference for people being excited about this. So now I was considering just walking through the protocol descriptions, because they are actually really simple, and I encourage you to read them. But on this computer, I'm not so sure if that will work out. Yeah. Okay. Let's see. No. So. Okay. Let's try here then. Okay. Yeah, they want help translating. Why not? Yeah, so they talk about privacy here, why it matters. There was some discussion, some debate about that, right? Why do we need privacy, or how much? This story is amazing. Somebody who made a phone call to a relative in Afghanistan and then was put in Guantanamo for 15 years. It's not a good situation. So SimpleX, they talk about what they do. I mentioned some of this ownership of the data, right? Everything is client side. I think that's a really good feature. And we can run our own servers. I talked about Signal being centralized with all the metadata. How's it different from Matrix, etc.? Well, there is no identity at all. It's really, every connection is a new connection. Quick install, platform design. So not the chat protocol, also not the server implementation. Here, this is what I want. So it's 900 lines. That's not really long for a protocol description, markdown. independent of any transmission system. So it works over TCP on the internet, right? But it can also use anything else, but it doesn't really care as long as the message format is the same. We could also use bridges, build bridges between lots of different transports. The data model or the communication model has 3 participants: the recipient, the server, and the sender. This order will make sense in a second. The server has these queues, message queues, and a queue is created by the recipient. So if I want to invite a contact to reach me, I prepare a queue for this, and I then provide some information in the QR code or in a link to the person I want to be reachable for. Right, and they then connect to the other side of the server, and then we have a one-way channel. They do the same, and then over this one-way channel, they send me how I will be able to reach them, and then we have a two-way channel, and this is all transparent, right? It happens just that the app does it. But these 2 paths, they don't need to go over the same server. They usually don't, and they don't identify us also in any way. That's also nice. So out of band messages, right? We need to do this initial contact out of band. SimpleX queue, as I said, right? It sends messages in one direction. Can be communicated in a link that has this syntax. So when, as I said, right, Alice and Bob, they want to communicate. Alice wants to receive messages from Bob. She creates the new queue. Creates a random key. Creates another random key. So the first one is for Bob to encrypt the contents of messages, and the second one is for Alice to communicate with the server. Oops. And then another key pair for one extra encryption layer that the server uses between itself and Alice, so that anything that goes into a server never comes out the same data never comes out. This is also a nice feature that I don't know that I've seen anywhere else. This makes correlation really, really difficult for anybody watching the server, right? Then Alice creates the queue with this new command. The server responds and says, here are the IDs that you and Bob need to use. Alice gives Bob this information, gives him first the public key for the messages, and then where the server is, and then his sender ID for this queue. Bob creates then his key for communicating with the server and prepares confirmation message to Alice. So he then sends through the server to Alice, okay, I'm here. Alice then receives this message from Bob and locks the queue to only work with Bob. Up until that point, anybody else who also guessed the information that Alice sent to Bob out of band could also have tried to connect, but only one. So the winner, the first one wins, and Bob would get an error message, and if Alice and Bob are communicating as they need to be out of band, then they will recognize that somebody is trying to mess with them. And that's it. Now this one-way communication from Bob to Alice has been established, and after that Bob does exactly the same thing to create a channel for Alice to reach Bob. Here's a nice diagram showing exactly this. And here's how the queue works once it has been established. So the recipient subscribes and is verified, then the sender subscribes and is verified, sends a message, the recipient fetches messages from the queue, that's it. It's really simple. And there's end-to-end encryption going on inside or of the message contents as well. But the server doesn't know and doesn't care. That's pretty much it, right? Multiple servers do not communicate with each other. They don't need to share any state. They don't need to know anything about each other. The clients decide everything. Servers need to store messages only until they are downloaded by the recipient. No history or logs need to be stored. Again, very unlike Matrix. And so what was this last point? Yeah, SimpleX queues one way. Crypto, it's using a lot of, it's using Salt, the Salt crypto box. It's using ED 24519, ED 448. Yeah, servers must not store and send stuff to other servers, sure. There are message delivery notifications, so and that's also a really nice, I think they've solved that nicely. So for mobile operating systems, there are proprietary services for push notifications, right? And we don't want to send the message contents, and we also don't want to send the metadata there. Here, there is a sort of extra subscription possible for a notification helper that will receive information that there is something to fetch in the queue, but not what it is and not from who and nothing else, and can send this through the proprietary push notification infrastructure. That's fun also. And it works really well. Even on so I heard the command line client actually also does this kind of notification on Mac OS, which is fun for Mac OS users. Here are the details of the block structure. It's quite simple, refreshing. So when I read through this detailed and slow, I had the feeling I'm actually able to implement this. It's gonna take maybe a week, but it's really straightforward, right? That's very nice. I haven't seen such a simple protocol in a while. Yeah, what are some interesting commands that we can take a look at? Acknowledge message delivery, suspend queue. I haven't tried that. Yeah, send message. Receive message. Okay, so has some depth, right, to the message structure, but it's all right. It's not so bad. Error responses. Yeah, transport protocol, TCP, whatever port, TLS 1.3 with this particular algorithm, CHA-20, Poly 1305, SHA-256, 24519, ED and X, key exchange and signatures. Strict, so a couple of really strict requirements on how the server behaves. The client has a possibility to reject the server if the server starts behaving strangely. Fixed size communication blocks, so 16 kilobyte communication blocks, that's good to not reveal how large messages are that are being sent. And 16 kilobyte is not so much overhead. I think that's okay. Yeah, and that's it. That's the end of the protocol specification. So let's see, page 9. That's all the protocol fun I want to go into, but I encourage you to look at the documentation. The documentation is really good. There's a user guide, and there's also a description of what the message protocol is for the contents of the messages. I didn't talk all about that. It's a very simple JSON format. Yeah, quite straightforward. So if you want to, you can connect to the Bornhack 23 SimpleX group. There's already like 15 people maybe in it once you've installed. And thank you to organizers and volunteers for making this event. And I'll take questions if you have any.
We have a question here.
Yeah, thanks for the talk. Actually, very interesting. As a Matrix user, I know that Matrix is really optimized for large rooms with large groups. And you said for the servers with SimpleX, they don't know if it's like a one-to-one connection or a connection to a group chat. And I wonder, how well does SimpleX scale for larger groups? And is that even a design goal to scale that much?
Right, excellent question. So at the moment, groups are the same as one-to-one. So if I'm in a group, I have a connection to everybody else in the group, and everybody else also has a connection to everybody else in the group. That doesn't scale so great. I don't know where the limit is, but it will be somewhere. And on the roadmap, they have this large group point. I don't know what the status is, but clearly somebody's thinking about it, and they want to also have a good solution for that.
Thank you. Someone in the middle of your talk, you mentioned that the server re-encrypts incoming messages into another key, sending it out, and that was good for stopping correlation effects. And then at the end, you mentioned a 16 kilobyte padding. Are those connected? Because without the padding, I could see that the correlation could be done anyway. Is these 16 kilobytes, is that the message size that will help, or what is that?
It's so the 16 kilobyte is a block size, so it's the smallest amount of data that will go out. Anything coming in or out of the server will be a multiple of 16 kilobytes. Does that answer the question?
Yeah.
Okay, and yes, correlation, there is the extra encryption on sending to the recipient, on the server sending to the recipient of a message, to make sure that what comes in is never what goes out.
Yeah, so thanks for the talk. I think I also read the protocol, and I thought it was a kind of nice take to do something really new. However, I also thought that this is very much a privacy focused, mostly privacy focused application, and for using broad scale communications with other people, it has some big flaws, I would say. Kind of hard to have this as the one app to use. So, and especially, for instance, if I were to have people contact me somehow, well, should you have email as a fallback as the first point of contact, or how would you go about doing it? And what happens if you lose your device? Because if I understood correctly, you can't really save your link to the persons you have, because then if you would use that shared link again, then it will be an error. So think if you lose your device and you have how would you go about doing it? And basically, can you see any problems, as I will see, having this as the only app in big quotation marks? Thanks.
So let me confirm I understood two questions. One question was how to use this for inviting anybody to contact me, anybody I don't know to contact me. And the second one was about how to handle the situation where I lose my device. Did I understand correctly? Okay, so let's start with the first one. I mentioned, it was quick, sorry about that. There are two kinds of invitations. There's a single-use invitation, but there's also a multi-use invitation. And this is a multi-use invitation. So it's possible to publish a multi-use invitation on a web page, on a slide, and any number of people can use this to connect to, in this case, the group. I could also put my own, one for me personally there. And I can revoke these at some later time. I will, after the event, I will revoke this, so make sure to join now. But I think the multi-use invitation is the solution for the first. And the second part, what do I do if I lose my device? Well, you restore the backup that you had made on a new device.
Other questions?
And personally, so once the multi-device feature is available, I'm really excited about this. I think this can work really for everyone and all use cases, right? Okay, so there's this broadcast and super large group. That's also an important feature, but I'm really enthusiastic about how this is going, and it's been around for not very long, so.
Thank you for the talk. Do you know if there's any progress on making a desktop client that's not the CLI one they have, or if anybody's working independently on implementations in other languages besides the Haskell?
So I've seen that they have a to-do for a desktop client. I don't know what the status is because I personally don't care, but a lot of people want that as well, that's true. And other implementations, well, my fingers are itching to implement this myself. So maybe there will be one at some point, but I'm not going to promise when. And other than that, I don't know. But you people should also create an implementation. Why not? It's pretty straightforward. And I think that's a good also call for action to well, either at a minimum, like integrate with what is there, but also look at creating more implementations. Was there one more over there? Okay.
Any other questions? Wait, there was one.
Yeah. Is this related to the very similar looking protocols on the surface level from Nostr and Session?
I don't know. I haven't looked at them.
Any other questions? Let's give a round of applause for Peter then.
Thank you.